me share my screen.
I have a question.
Sure.
Is there a quiz due the 18th? And if there is, where do I find it?
Well, I'll tell you what. You are 30 seconds ahead of me. Today we're going to look at quadratics. There is a quiz that will be available after class today that will be due by midnight tomorrow. It's it's in my labs. You must, oh Lord, what happened with my typing there? You must submit your work in Blackboard to receive any credit.
It's due tomorrow, not the 18th?
I think that in my labs it's open till tomorrow. I think that the thing in Blackboard, the Dropbox, will be there till the 18th, in case somebody does it really, really late on the 17th and doesn't get to turn in their work until, after midnight.
Okay.
Okay.
Yep.
If that time frame is problematic for anybody, reach out to me before the end of the day. Otherwise, on the quiz, there is a equation, a first degree equation for you to solve. There's a fractional equation for you to solve. And then there's problems using your operations on complex numbers, imaginary numbers and complex numbers. Can you guys hear me okay, or do I need to use that headphone set today?
You're fine.
Okay. All right. Before we get started with the new stuff, does anybody want to look at any homework questions?
Yes.
Which assignment, which question?
The one that's due tonight.
Okay.
I think it is.
Uh-huh.
And then some of the last questions, like 15, 16, one of the ones that get kind of complicated.
Okay. 15, actually, I think its bark is worse than its bite. 15, what you've got, first of all, are two things that have negatives under the radical. And so remember we said if you have a negative under the radical, the very first thing you want to do is put it in terms of I. So if I have 5 times the square root of negative 7, that's 5 times the square root of 7 times negative 1. So that gives me 5 times the square root of 7 times I. In the same way, where I have negative 5 times the square root of negative 12, well, that's negative 5 times, let's see, 12 I can break up into 4 times 3. And then I have the negative 1. And so that gives me negative 5 times 2 times the square root of 3 times I. And so that one becomes negative 10 radical 3 times I. I did that a little fast. Did you follow, or do you need a slow-mo instant replay?
I think I got it.
So what I'm doing is I'm putting them each in terms of I because there's a negative under the radical, and I'm simplifying the radical if I can. Now if I'm multiplying, adding and subtracting, they have to be like terms, they have to be like radicals. Addition and subtraction is very mean. You have to be the same or I'm not going to mess with you. It's very discriminatory. Multiplication and division are much more accepting. I can multiply anybody. So multiplying 5 times negative 10 is negative 50. Multiplying the radical, 7 times 3 is 21. Multiplying the imaginary units, I times I is I squared. That part all right.
Yes. Lincoln is here.
Yeah, remind me at the end of the class to add you to attendance. And then I squared is negative 1. So that's negative 50 radical 21 times negative 1. So my final answer would be 50 radical 21. Go ahead.
I was just going to say, can you multiply those two numbers to get a positive?
Beautiful. Excellent. Spot on. So was it as bad as it first looked?
No, it wasn't.
Good. Should we look at another one?
Yeah, can you look at, I think 18 or 17 looked pretty difficult. I don't know, one of the two. I just knew that they got really hard, and I was like, I don't know how to do that.
Okay, we want to evaluate, here we've got x squared plus 14 over 4 minus x, and we're told that x is I. So substituting, that's I squared plus 14 over 4 minus I. What's I squared?
-1.
So -1 plus 14, beautiful, over 4 minus I.
Oh, that's a simple. Isn't that a simple?
We're not quite, simple substitution, yes, but we're not quite done yet because we still have the I in the basement. And do you remember, if we have I in the denominator of a fraction, can you remember what we said we had to multiply numerator and denominator by to get that I out?
The conjugate?
So that would be 4 plus I.
Yes.
And so that gives me 13 times 4, I believe, is 52, plus 13 times I. Over in the denominator, I'd have 4 squared minus I squared.
Yes, and then which is then 16 minus -1.
Which is 17.
Yeah.
The final answer is 52 over 17 plus 13 over 17I. And I want to split it up because they say specifically A plus BI form. So that tells me take that one fraction, turn it into 2 fractions, and then pull your I out so that you have a coefficient of 1.
Okay.
Okay?
Yeah,
Better?
thank you. Yeah, much better.
Okay.
Can you go over 12?
Sure. Number 12, you're supposed to put them in terms of I first. So let's see, we've got 7 times the square root of -9. Are you all right? That's 7 times the square root of 9 times -1. So that's 7 times, what's the square root of 9?
3.
And the square root of -1 is I, so that's 21I. Plus 5 times the square root of -25 would be 5 times the square root of 25 times -1 would be 5 times 5 times I, or 25I. And so that adds to 46I. I think they should accept 46I. If they tell you it's not an A plus BI form, they might want you to write it as 0 plus 46I, but I think that 46I should suffice. Better?
Yes, thank you.
Okay. Any others? And do you notice when we're doing this stuff that in many ways I acts like X would, like a variable? The only thing you have to remember is never leave an exponent on I squared is -1. I to the third is -I. I to the fourth is 1. If these are all right, I'm going to try to pick up from where we left off. And if I remember, we had defined a quadratic equation as being an equation that's second degree. And we talked about solving a quadratic. And we had gone through method 1, which was by factoring. And let's look at one more example of a quadratic equation that we'll try to solve by factoring. And so this time I'm going to say I have 2x times x minus 3 is equal to 5x squared minus 7x. I'm open to suggestions. What would you folks want to do first with this one?
Distribute.
Distribute,
Beautiful.
yeah.
This simplified gives me 2x squared minus 6x equals 5x squared minus 7x. Now we want to put it in standard form. So we'll get all of the x squareds together, subtracting 2x squared from both sides, giving me negative 6x equals 3x squared minus 7x. In order to solve by factoring, we want one side 0. So let's add that 6x to both sides. Gives me 0 equals 3x squared plus x. Now that it's in standard form, we want to factor. How would you folks factor this? First thing I say to myself is, self, is there anything in common? Is there a common factor here?
X.
Beautiful. And when I factor that out, I'm left with 3x plus 1. Now when I set each factor equal to 0, one solution is that x equals 0. And then we have to solve this to get the other.
Quick question.
Go ahead.
The negative 7 and plus 6, wouldn't that be minus x?
Yes, it would. Thank you for keeping me honest. I think I can fix that going through with a sleight of hand. And so we get our other solution is 1/3. Thank you very much. Sorry about that. And so this method is solving a quadratic equation by factoring. I'm guessing that a lot of you might have seen that in the school class. If you have not seen that before, that's really one of the major places we factor to help us solve these quadratic equations.
You're breaking in and out really bad.
Okay, headphone time. Better? Is that better, folks?
Not
Can you
really.
hear me? Not really.
Oh, now it is.
Okay. Then if everybody's comfortable with solving by factoring, I think last class we alluded to the second method. And that's to use the square root property. And what the square root property says is if x squared is equal to some value then n, then x will equal plus or minus the square root of n. And so let's look at an example. Let's look at x squared plus 1 equals 0. And the first thing I'm wondering, is that factorable? Can I factor that binomial? Two terms, nothing in common. They're both perfect squares, but there's a plus sign in the middle. So this one I cannot factor. So I'm going to try to use the square root property. And in order to use the square root property, the first thing that I want to do is isolate the perfect square. And so as I look at this, I'm going to isolate that x squared. To get that alone, I'll subtract 1 from both sides. And that gives me x squared equals -1. Now, I'm going to use the square root property to take the square root of both sides. So I'll take the square root of x squared, and I'll take plus or minus the square root of -1. And that will give me x equals, what is the square root of -1?
So it'd be a -1 and positive. Is there even a square root for -1?
Sure, I. That's what we've been working with. Right? Isn't it the square root of -1, I?
Oh, yeah, it is.
Positive I or negative I. And so that's one of the reasons that we need this I. We need to be able to solve equations. That might not have real roots. Another example, if I have x squared minus 27 equals 0, is everybody all right that this one is not factorable?
Quick question about the I.
Yeah.
I always thought I was always a negative number. There's a positive I.
You can have a positive I. I is always the square root of a negative number.
Oh, okay.
That is the square root of -1 equals I. And so my two solutions are I, and then I have to have that second negative possibility, negative I.
Okay.
Is everybody right? This one's not factorable. So the first thing that I want to do is get the perfect square alone. So that gives me x squared equals 27. And then when I take the root of that, I'll get x can equal the positive square root of 27, or x can equal the negative square root of 27. Do you think I should leave that square root of 27, or can we simplify that?
You'd simplify. Yeah.
Goes into 27 evenly. Can we look at that as 9 times 3? So that gives me x equals 3 radical 3, or x equals -3 radical 3. And those would be my two solutions. Next example is a little bit more involved. Is everybody done with this one?
Yep.
Next example, let's look at x minus 3 quantity squared equals 81. The way in which we were doing this last class, remember we took and we multiplied that left-hand side out. However, this time, if I use the square root property, does everybody see that what I have on the left is a perfect square? So when I go ahead and take the root of each side, I get x minus 3 equals 9, or x minus 3 equals negative 9. And now I can solve for x by adding 3 to both sides. On the left, I get 12. And adding 3 to both sides on the right, I get negative 6. How's that one? I think if you can see that use of the square root property, as long as what you've got is a perfect square and there are no variables on the other side. So over here we have a constant. We can make use of that square root property. And I think it's a little bit easier than multiplying that out to begin with. The next one's going to be even more fun. This time, let's take 2x plus 4, quantity squared, equals negative 64. Again, if you want to, you could, I have no idea why that's showing up at the bottom. If you want to, you could FOIL the left-hand side out, bring everything over to one side, and try to factor. But being that, does everybody see the left-hand side is a perfect square? I've got this binomial squared, and the right-hand side is a constant. I'm going to use my square root property. And so I'll get, taking the square root of both sides, the square root of 2x plus 4, quantity squared, is equal to plus or minus the square root of negative 64. So on the left, I get, taking the square root of that square, 2x plus 4. Oh dear, over here where I have a negative 64, I have to think of that as 64 times negative 1, which will give me 8i, or I'll get that 2x plus 4 is equal to negative 8i. We took a big leap of faith there involving the I. Is everybody comfortable with that? Not hearing any complaints, I'm going to go ahead now and solve each side for x. On the left, I'll subtract 4 from both sides, and I get 2x equals, everybody remember, these are not like, I'm going to have to leave that as negative 4 plus 8i. And then to solve for x, we'll divide by 2. And we'll get x equals negative 2 plus 4i, remembering that we have to divide both terms of that numerator by the 2. And then I'm going to do similar work on the other side. Subtracting 4 from both will give me 2x equals, again, the real and the imaginary are not like. I have to leave them separate to get this complex number, which I'll divide by 2. And again, remember both the -4 and the -8i need to be divided by 2. Then I get -2 minus 4i. And so those would be my two solutions. What we haven't done with these ones with complex solutions is a check. So is everybody all right if I check in the original 2x plus 4 quantity squared has to equal -64. And let's check first x equals -2 plus 4i. That gives me 2 times -2 plus 4i quantity squared equals -64. Inside parentheses, I'll distribute. That gives me -4. Oh, Lord. It would help if I wrote the entire thing. Sorry about that, folks. That's 2x plus 4 squared. That gives me -4 plus 8i plus 4 squared, or 8i squared, which would give me 64i squared, which is indeed -64. Checking the other, it's 2 times x is -2 minus 4i, 2x plus 4, quantity squared is supposed to equal -64. Again, distributing to start, I get -4 minus 8i plus 4 squared. Simplifying inside the parentheses, I get -8i squared. -8 squared is 64. I squared is -1. And so that does equal -64.
Can you pause for a minute?
Sure.
Thank you. All good, thank you.
Okay. Then, if that's all right, we're going to take that reasoning and go a little bit further and come up with another method of solving a quadratic. And method 3 involves completing the square. And we're going to do a little bit of background work before we actually look at how to solve a quadratic by completing the square. But when I complete a square, what I want to do is I want to turn a binomial into a perfect square trinomial. By adding a constant. At which point you might want to say, what's a perfect square trinomial? And a perfect square trinomial is a binomial square. And so I'm going to ask you folks to do a little bit of multiplication for me and see if we can notice a pattern when we start squaring binomials. If I take x plus 1 and square it, off on scrap paper land, I'm going to take x plus 1 and multiply it by x plus 1. And either boxing or distributing, I'll get x squared plus 1x plus 1x plus 1, or x squared plus 2x plus 1. And that's interesting. I'm going to be quiet for a minute and ask you folks to please do the algebra on your own to take x minus 2 and square it, and tell me what you notice, or tell me what you get. Anybody done multiplying yet? Did anybody get x squared minus 4x plus 4?
Yes.
So let's see what happens when we take x plus 3 and square it. Did anybody else get x squared plus 6x plus 9? And if I, well, let's do one more. Let's look at x minus 4 squared.
So is there a reason why you're doing the plus 1 and then the minus 2 plus 3 and minus 4, like switching the terms? Or is...
I just want to show that the same thing holds no matter what the sign.
Oh, okay.
Okay. So this one, when you multiply it out, what do you get? I'm betting it starts with x squared. I'm betting it ends with plus 16. And what's in the middle? Minus
8x.
Minus 8x. And so let's look at what all of these have in common and see if we can generate that rule for a plus b squared. Is everybody all right that all of them, the very first term is the first term squared? Does everybody notice the very last term is the last term squared? And so now what we have to do is we have to figure out what's going on with these middle terms. This negative 8x. Isn't that double minus 4 times x? This positive 6x. Isn't it double 3 times x? This negative 4x. Isn't it double negative 2 times x? This 2x. Isn't it double 1 times x? And so doesn't that term turn out to be 2ab? Multiply the terms in your binomial that you're squaring and then double it. And so using that idea, go ahead.
So if it's what if it's like a minus b squared? Is it the same thing, but in the middle one it's negative instead of positive?
Right. Because we can think of that -4 as being -4. And when I double the -4, I get the -8.
Okay.
So then we have to figure out what would I add to each of the following. To get a perfect square trinomial. And I'm going to start with, let's say, x squared plus 12x plus something. When I look at that 12, if I look at it compared to a squared plus 2ab plus b squared, isn't that 12 double what I would have to square here? And so to fill in the blank here, wouldn't I take the 12, divide it by 2, and square it? 12 divided by 2 is 12 divided by 2 is 6. So if I add that 6 squared, don't I get x squared plus 12x plus 36? That would be my x plus 6 squared.
How exactly again did you get the fraction of 2? Sorry, I was writing stuff down.
We had said that this middle term is always twice the product.
Oh, okay.
So to find if I know the middle term, to find out what I have to square, I know that middle term is twice what I need. So I will always divide the coefficient on x by 2, then square that. And I apologize. I misspoke just a little bit. This will only work if the leading coefficient is 1. If I have a number in front of the x squared, this method gets shot to hell, and I have to do a bit more work. So let's say I have x squared. Oh, you know what? Let's get all crazy. Instead of putting a plus, let's put it in a minus. X squared minus 18x. What would I put in that middle, in that space to find that missing term?
18 over 2 squared?
So 18 over 2 squared would be 9 squared, which is 81. So if I add 81, that becomes x squared minus 18x plus 81. And wouldn't that factor into x minus 9 squared? And so we're always going to take half of that coefficient of x, square it, and add to both sides. So how is that going to help us solve a quadratic? The first example I'm going to look at is one that would be factorable, and I think we've already solved it by factoring. But I want to set the first one I do by completing the square. I want to make sure we get nice answers. So to solve a quadratic, by completing the square, and let's again look at an example that's pretty straightforward. That would have been factorable, but again, I know it's factorable. I just want to start with an example where you have pretty numbers, so to speak. The first thing that I want to do is isolate the constant. So I want to get all of the variables on one side of the equation and the constant on the other. Which means over here, is everybody right? The constant term is 8. So I'll subtract 8 from both sides, giving me x squared plus 6x. I'm going to leave a plus in there, but I'm going to have a blank. Next thing, we have to divide both sides by the leading coefficient to get a leading coefficient of 1. Does everybody see with this problem? I don't need to do that because I already have the leading coefficient of 1. Now we want to add a constant to both sides. To get a perfect square trinomial. And again, in order to do that, we said we take the coefficient on the plain old x, divide it by 2, and square it. So 6 divided by 2 is 3 squared, which is 9. So I'm going to add 9 to both sides. And so we'll write that as x plus 3 squared equals 1. And then we'll solve using the square root property. So taking the square root of both sides, I get x plus 3 equals the square root of 1, or x plus 3 equals the negative square root of 1. Here, if x plus 3 equals 1, when I solve by subtracting 3 from both sides, I get x equals negative 2. And over here, if x plus 3 equals negative 1, when I solve again by subtracting 3 from both sides, I get x equals negative 4. And so my solutions are negative 2 and negative 4. And again, we should always check in the original. And so our original was x squared plus 6x plus 8 equals 0. So let's take negative 2 squared plus 6 times negative 2 plus 8. Does that equal 0? 4 minus 12 plus 8 is indeed 0. So it checks. And then checking the other solution, negative 4 squared plus 6 times negative 4 plus 8. Does that equal 0? So that's 16 minus 24 plus 8 is 0. So it checks. How's that look? Let's try another example. Can I turn the page?
Yep.
Next example. Let's solve x squared minus 2x minus 5 equals 0. And usually when I solve, I kind of have a checklist I go through. And I'm looking at this one, and I know that I cannot factor it. Since I can't factor it, I'm going to try to complete the square. I'll add 5 to both sides, which gives me x squared minus 2x equals 5. What would I add to make that a perfect square trinomial? Okay, I always look at that x coefficient, negative 2. We're always going to divide it by 2 and square it. So that's negative 1 squared, which is 1. So I'll add 1 to both sides, which gives me x squared minus 2x plus 1 equals 6. What's on the left isn't just factorable, but it's clearly a perfect square. And now that I've got that perfect square, I can use my square root property, giving me x minus 1 can equal the square root of 6, or x minus 1 can equal the negative square root of 6. And when I add 1 to both sides, I get x equals 1 plus the square root of 6. Or here, when I add 1 to both sides, I get x equals 1 minus the square root of 6. What do you think?
So when you add the negative 1 over, oh, you do positive 1?
Remember, after we have it, you have to square it.
Okay,
Square negative 1, I get positive 1.
sorry.
Okay, don't apologize. I'm going to put one more up here for you folks to try on your own. I'll give you a couple minutes. Ready? Let's look at x squared minus 2x. Oh, no, let's not. I'm copying the wrong one down. Let's try it again. Let's look at x squared plus 4x plus 13 equals 0. And I'll tell you in advance that one does not factor. So I'm going to ask you to solve by completing the square. How are you folks doing?
I kind of hit a brick wall when I got to x plus 2 squared equals negative 13. I feel like I'm doing it wrong.
No, you're doing it perfectly right. Let's go
Okay.
through. I like where you are. I'm going to, oh, no, there's one tiny problem. I take that back. I lied.
Okay.
This x squared plus 4x equals negative 13. And I'm guessing that you took the 4, divided it by 2, and squared it to get 2 squared, or 4. And the only problem you have is when you add 4 to one side of the equation, you've got to remember to do it to both sides. Right? Whatever you do to one
Okay.
side of it. And so that gives me that x plus 2 squared equals not negative 13, but negative 9.
Okay. Okay. I see what I did wrong.
Okay. I would almost write that off as a typographical error. Little tiny careless mistake. Otherwise, that you got x plus 2 squared, tell me you were well on your way. Now this gives me x plus 2 equals the square root of negative 9, or x plus 2 equals the negative square root of negative 9. And is everybody all right if I've got a negative under the radical? I need my I. X plus 2 equals 3i. Subtracting 2 takes me to x equals negative 2 plus 3i. And over here, x plus 2 equals negative 3i. Subtracting 2 takes me to the x equals negative 2 minus 3i. And I'm looking at what we've done so far today and where I want to go next. And I'm thinking that where we go next will probably be more comfortable for you folks if you take some time to practice completing the square. So I'm going to stop here today. I want to go back and look at that homework. This homework that's due October 21st. Right now, questions 1 through 20 are on what we did today. If you're brave, you can go past there if you're familiar with the quadratic formula, you can go past there. But over the weekend, try to get through 1 through 20 on that homework 1.5, and we'll pick up with that next concept on Monday, because where we're going next is what this work we're doing for completing the square. We want to do, because it gets to be a little bit annoying doing it every time. We want to do that with a general quadratic with variables, and we'll come up with a formula. But to this point, how is everybody with what we've done today? Lincoln, I have to add you. Any questions? Would it hurt anybody's feelings terribly if we ended class just a little bit early today?
So where's the quiz going to be, on Blackboard or My Math Labs?
The quiz is in both. The questions are in My Math Labs, but I am not going to grade your quiz. I'm not going to take that grade from My Labs and put it into Blackboard unless you submit your work in Blackboard. So let me take a quick second and show you guys what I mean. The quiz will, whoops. Let's try that again. I thought I clicked on show all. The quiz shows up here, quiz October 16th in My Labs. It will show up for you guys. Why am I having it showing up at 1? It'll show up at 1. But if you go into Blackboard, in content, in tests and quizzes, there's a place for you to submit your work for the quiz October 16th. So again, you're putting your answers in My Labs, but you're putting your work here. And as I click on that, again, I think it's easiest if you do this by opening Blackboard in your phone. And if I open Blackboard in my phone, if I click on that, browse my computer, it will open the camera on your phone and you'll be able to take those pictures and submit them right away. So the quiz is in My Labs, but you must, in addition to putting your answers in My Labs, do neat, legible, numbered work on separate paper and submit that in My Labs in order to get credit.
What is the quiz on?
The quiz has a couple of equations, first degree equation, a linear equation, but it's got a few parentheses in there. You have to remember your order of operations. An equation with fractional fractions for coefficients, a rational equation with the variables in the denominator. Those would be like the questions that were in homework 1.2. And then there are some questions that involve your complex numbers, like in homework 1.4. I don't remember putting a word problem in there. So that, let me just real quick double check so that I'm not making a liar of myself. Let's see. Yep, that's first degree equation in one variable, first degree equation with fractions in the coefficients in one variable, a rational equation, adding and subtracting complex numbers and multiplying complex numbers. Okay, 5 questions. All right, anything else? If not, I'm going to stop recording and say have a great weekend.